some feedback from the audience? Okay, thank you. Okay, I think I am not a career academic. So I'm coming from industry, and for me, it was quite a change to go from doing systems engineering and systems thinking to teaching. And for this paper, I did as a taking stock of what I'm doing and to try and have some self-improvement to understand what I need to achieve, where I am at now, am I making a success of it, and to try and get things better done and to get some feedback on where to improve, what to improve in this field of teaching. So this is just the content. I'm going to talk briefly about the course content that I teach at the Graduate School of Technology Management and some lessons learned from the past 3 years of presenting these courses, and also some concluding remarks. I tried to get Dali from the ChatGPT to create the image of teaching systems thinking to students. This is what it came up with. What was quite interesting is a lot of gibberish. I don't know if people see systems thinking this specific way. Is it the message, or is it just trying to prevent people analyzing what it is saying? It's just totally dumbing it down. Huh? Yeah, well, that was the best picture I could get. There were much more ugly pictures in this one. So yeah, I've built in as a sort of a comic relief a lot of ChatGPT and AI type things into the course generation. When I said generate a systems thinking tool for me, I think you guys can even I've built one, so I'm happy about this one. Just to set the scene, the way I see systems thinking that I present in my courses is that systems thinking is a system of thinking about systems, and it's been noted that it's becoming increasingly important as the problems we are trying to solve is getting more and more complex. And systems thinking employs the tools to investigate and model and illustrate system behavior to help inform decisions about policies and generating solutions to the problems that we have. So just some background on the course. We are teaching to engineering and project managers. Because we are a postgraduate school, and most of the courses currently, since COVID, has been remained to be online, and the course is part-time. It's not a full-time course. The typical students who get in these courses, they are 30 to 40 years old. They have a couple of years experience in industry, so they are quite a mature audience that we have to teach, and they normally come from the STEM environment. Mostly engineers that try to go into engineering management. The Masters in Engineering Management can be compared to an MBA for engineers, where we have a number of modules or courses, the modules in management sciences, as well as some high-level engineering type sciences as well. The school, we get about between 150 and 170 students annually. I think it was a bit down during COVID, but it's just slowly picking up again. And the distribution between the engineering management, the project management, and the technology management is roughly 40, 35, 25%. Where the biggest portion is coming from engineering management. And myself, I'm presenting the systems thinking and the systems engineering modules. Systems engineering is a core module for engineering management and an elective for technology and project management. Systems thinking around that is just an elective for all the modules. Recently, over the last year or so, I get about between 20 and 50 students for systems thinking, where we have 10 elective modules and students can pick 2 of them for the first semester in the second year. So it's a semester module. So roughly, I can see that systems thinking is getting equal attention from all the other elective modules that the students can pick. When I look at the honors course that we also present the honors in technology and engineering management. The systems thinking is combined with systems engineering, so it's actually half the amount of workload that we present in, for the master students. And the aim what I have for this module is to equip students to be systems thinkers, to be a support the other thinking and decision making they have to do in their daily, mostly engineering management tasks. So briefly, we look at the course structure. It is a semester module where it is part-time. So we have a 2.5 days contact session with the students, full days. So you have to cover all of your material that you would like to transmit to the students in 2.5 days, full-time, 8 to 5. The course can basically be broken up into a preparatory phase before the class. That's roughly a month and a half, where students have to read some, do some high-level assignments on the material I'd like to cover, to let them not come into the classes cold. In the classes, there are formal lectures currently, and also intermingled with some bit of group work to break the boringness. And then after the contact session, there are a number of group and individual assignments that the students have to complete to test and exercise the tools that they've learned, and to show that they can perform systems thinking on real life and real world problems. So if I, at a high level, look at the course content, firstly, of course, you start with systems, defining systems. What is a system? How do you look at systems around you, looking at the elements, the interactions, to understand how systems work. This is roughly the same that we do in systems engineering as well. And also with a bit of a special focus, looking at the more complex and intricate and messy problems. After that, we delve into systems thinking principles to try and identify the processes, the tools, the skills you need for systems thinking, definitions thereof, and to see how can you apply systems thinking to address these complex, wicked, and messy problems. Then you spend a lot of time on the various tools. Systems thinking can be seen as a whole conglomeration of various thinking tools that we apply in order to understand and analyze these complex systems. The things that we focus on are include the iceberg model, rich pictures, the telegrams, then some thinking tools, root cause analysis, and critical thinking. I touched briefly on soft systems method and the design thinking, and culminating down to the system archetypes. Give a feeling for the students of how to identify the typical systems that they encounter. This is roughly where the honors students will stop at their level, but the pinnacle of the course will then be system dynamics. To apply it, to do some causal loops, stock and flow diagrams, and to get eventually, hopefully at the end of the course, being able to model and simulate and run a system dynamics model. That is in the ideal world. Of course, any course must have some assessments. The assessments that we have to spread out the various types of assessments. In pre-class, there's a test that you do on the first morning of the first class, just to check that everybody's been doing and learning the work. Then there's also an individual pre-class assignment, but basically focus on identifying at the high-level model of a wicked and messy problem, typically in South Africa. The typical things come out like poverty, corruption, energy crisis, all those type of things that we struggle every day. During the class, we have some group work going. This is where we show them how to implement this and uses different systems thinking tools, where they can start drawing some causal diagrams, identify archetypes, to identify and to analyze the problem. And then afterwards, we have an individual assignment where they have to get a system dynamics model running and going and testing some sort of policy. One thing I have to note here, and I've been thinking about this while writing this paper, is As opposed to other courses that I've seen, they give you a problem with formulas and definitions. We think you have to convert that into a stop and flow diagram, which is not that difficult. But to have an open-ended problem without definitions, it's a lot more difficult to try and generate a running system dynamics model with. And that's one thing I've played around with to maybe improve this aspect of it. So that makes it a bit difficult for students. So in feedback that I've received on the course up to now is normally the writing scores that I give a lecturer and then our group have done. That's normally a very good score relatively what I've seen to other scores in the school. Students actually make comments about that they like these new tools, the new skills they learn. They can see they can apply them in their daily life, and I think in general students are quite happy with it. The things that they struggle with is to do the stop and flow modeling and the diagram. Doing that, it's a bit complicated, especially only having a 2-hour session teaching you how to do specific system dynamics modeling. That's very difficult. And this running of this final assignment, getting to the top level, is only the top students in the class that take it. Just less than a third of the students actually get a good system dynamics model running that makes sense to you. The assessment is structured as such as if you can just get up to at least done a good causal loop diagram of the problem, it is possible to pass that assignment. But to get good marks and this distinction, you need to be able to get the simulation going. Also, we noted that in the last, since I've been presenting the course, it's nearly doubled the amount of students that picked the course. So I think that's a good sign as well. The problems that I've experienced is it's very difficult with the limited context for students to teach them proper system dynamics. It is not that easy to get that level of achievement. It is found that in the contact session, you spend a lot of time teaching the what of system engineering, what to do, but not necessarily exercising how you are doing it. Getting real-time feedback on that. And with the group work assignments and working with between the people, it's not always that easy to get that in the class, but within the short period. What I've also done, and this is also a ChatGPT of Delphi, this is of course a loop diagram that they think it is. A lot of gibberish as well. It seems that there's not a lot of good literature out there to teach these large language models about. I've done in the past a paper on what research in systems thinking is about, what are the different topics we talked about in research. At the top, the descending order is about complex systems, system engineering, the practice of doing system dynamics modeling, enable organizational management, do policy analysis, change management, and then sustainable development. In this sense, I feel that I am addressing most of those in terms of the module that I do, and enabling students to be able to do the practice and achieve some system dynamics modeling. What I've also done is I went to ChatGPT and asked ChatGPT what is a good curriculum for the system thinking course. Especially, I think I did specify at a master's level. So the highlights, the objectives that they identified is to the foundational concepts, be able to analyze and model complex systems, cultivate critical thinking, problem solving skills, and do a practical systems thinking application to real world challenges. I try to do that, but I'm not sure if I always am successful. And the type of assessments that it provides is roughly what I've been doing as well. So ChatGPT in general concur with what I've been trying to achieve. The curriculum itself that it proposes is obviously introduction to systems thinking, then to looking at the system concepts and framework, identifying elements, interactions, boundaries, causal loops, then system archetypes. Quite nice. Doing some systems mapping and analysis, root cause analysis to identify the causes and effects, and then to do a system dynamic simulation. to identify and experiment with the new response. I think, I think I've achieved that, but what it also added is to use systems thinking in decision making. I think that is one area that is not used that much anymore or yet. To support of decision making complex systems, identify and mitigate unintended consequences, and also ethical considerations. If you look at data that you apply and on the application of systems. These things I see as your lifelong learning. You've taught yourself, or you learned these skills in the class, but there's a lot of work afterwards that you have to continuously work on and growing for you to improve. So the things that I think of adding to improving is to move more of the course material on the what to before the course, to do more intensive preparation for the course, do the theory before the course, before the contact session, and then inside the contact session to have more practical exercises, exercising the how, giving students more and more feedback. You can quickly pick up, after you've spent an hour teaching a causal loop diagram, sending them away for 2 hours to struggle to construct one, and then come back and give them feedback on the attempts. You can see the lights coming up in the students when you work through that, being asking me questions about the wording they use in their notes, the wording and the directions of the links, and the polarity of the links. And when you start kicking that around, asking the questions, you can see the lights coming up. And the idea is to spend more time on that. And maybe we're actually critiquing each other, saving time then on me talking to them. Also looking into the availability of software tools, free for specifically to help them test and play around with these concepts. The systemic tool for systemic graphs, very nice. When somebody knows for basic modeling is available in free. And then I also like to use looping to show very quick and dirty how causal loops work. And then at the end to spend more time on real world examples, real life actual case studies that they can apply to test and exercise these skills that they've been learned. Okay, so in conclusion, with this course being presented to engineers, they have a different need for systems thinking for these engineering managers than say maybe biologists or people doing nature management, but that they have other scientific requirements for systems thinking. So this is a bit more specific to engineers and the way we work and the type of management problems we have. Your curriculum, it requires a structured approach, cover all the key concepts. I have to focus on encouraging the critical thinking and problem solving, getting more practical applications that they can look at, and then to help them focus their systems thinking skills. And I think these skills are something that you need exercising, get good systems thinkers. And then and another thing that I also think of is this is my paper is about for masters, maybe honor students. What about pre-grad? What about schools? High school, primary school. If we want to get systems thinking in those environments, what level of systems thinking do we need to teach them to be relevant and sensible for their environments? I think there is a lot of thinking that have to go into this to give the right level and the right set of skills for solving your complex problems in your environment.
I just
Yes.
stop. Yes.